So when we start talking about infrastructure as a service and identity and access management services for it, well, let me start with an introduction. I'm Mark Diodati. I am Research Vice President and the Agenda Manager for Gartner for Technical Professionals here at Gartner. So we have about 70% of the Fortune 500, maybe 60% of the Global 1000 as clients. And they ask us some frequent questions about identity management and IaaS. The first one is, and it's the biggest one, is how can I leverage Azure AD to facilitate identity and access management for AWS, right? And what they're really asking sometimes is also the second question we get, which is, how can I improve the MFA for my AWS administrators? If you know anything about AWS, you would know that the IAM users are quite siloed, and it's difficult to implement good MFA. AWS has some smaller, not so great non-modern MFA, but what we really want is to be able to use things like Azure AD Conditional Access, MFA, maybe even bolt in a third-party provider and so on. And so we're going to tackle that across two different dimensions. The first one is I've created two applications which you're going to have to take on an imaginary trip with me. The first application, in fact, what it does is it synchronizes users from Azure AD into a Cognito user pool. Well, why are we using a Cognito user pool in AWS instead of the IAM user store? Because the Cognito user pool is the only identity store, and there are about 6 of them within AWS. That's part of the complexity of identity and access management within AWS. We have IAM user store, we have Cloud Directory, we have got Cognito user pool, we've got managed AD, we've all kinds of things. The Cognito user pool is the only one you can actually store users in and integrate OpenID Connect and OAuth with. So that's what we would use. And in the process, the best practices of doing that would be to actually use a client connect flow. Any luck, Jason? I'm tap dancing as best I can. Well, we'll actually see if we can make this work. So 2 real applications here, as you can see, in 3D. The first one is that user management exercise, where in fact, we're going to synchronize users from AD into Cognito user pool. And then the second one is a single page app where, see, I'm not tethered by the keyboard anymore. I'm trying to make lemonade out of lemons. The second thing we're going to do is we have a single page application that enables us to manage VMs, that is EC2 instances and Azure VMs, across that environment using a combination of OAuth, OpenID Connect, Azure AD Conditional Access, and Azure MFA. What's nice about those particular examples to me is that they give you this 360-degree view of a couple things. One is a service-side example of how to integrate IaaS environments. The other one is a client-side. And then the second one, as identity practitioners, we're kind of doing 2 things all the time, right? The first one that we do is we have to manage users, get them into systems entitlement. We call that admin time activity. And then the second one that we have to do is we actually do the business of giving them access and doing multi-factor authentication. And so these 2 particular examples, and I'd be happy to show them to you perhaps in the sunlight of the Heinz Convention Center at some point after this presentation. But to get there, we have to kind of talk a little bit about what the environments look like. So here's a traditional environment of AWS, right? You have, AWS calls it an account, which is just an antiquated name for a tenant. It starts from the days when we had accounts and there was only one account within a specific tenant. And then you would have resources into it. And as I said before, you have lots of users living in lots of different places. The only one that's really sufficient for us is the Cognito user pool. Because again, it's the only place we can define users and actually use something like OpenID Connect or multi-factor and so on to actually do it. Now, I don't have time, we obviously don't have time to go into more specifics around the architecture of AWS. It's quite complicated. And there's an emerging infrastructure around AWS now with this concept of AWS organizations and AWS single sign-on to build this N-tier level of accounts or tenants. And these tools are just beginning to emerge. And so you can have this N-tier level thing. It's kind of like looking at what's that phrase? You look at your fingernail, the pinhead of an angel or something. Suddenly you just had this one view of what AWS looks like, and then your mind gets blown. This is definitely emerging. In particular, some of the AWS SSO stuff isn't fully baked yet. The Azure architecture is relatively simple to understand in that you have one Azure AD, and you can have multiple IaaS tenants underneath it. So one Azure AD identity namespace, and then you can have n number of tenants with IaaS resources in it. Now, that means, obviously, the converse is true. A tenant can have only one Azure AD instance of namespace. And from there, you have your usual VMs, AI, ML, and so on. Let's take a look at this first application. So it was written in Python, and I don't have the video here to show you because that's not on the thumb drive. But essentially what it does is it uses a client credentials flow to synchronize users from Azure AD into Cognito user pools. It does not need to use an SDK for Azure. You can use bare wire for Azure. It's simple REST calls, and if you're familiar with OAuth, you're good to go. With AWS, you always have to use a toolkit. The reason you have to use a toolkit for AWS is because every call is digitally signed using what they call a SIG4 algorithm. It's terribly complicated to get right. I know of no single client, in fact, that can actually make API calls without using the SDKs that are provided. And from here, what ends up happening is you end up synchronizing them. And I don't have the slide to show you, but oh, here it is. Doesn't that look terribly complicated when it's 3D like that? I'll try and walk you through it as best I can. But essentially, in my live environment, and happy to show you this outside when we actually have a functional environment, is I create some users in PowerShell on an Active Directory environment. So this is straight ahead Windows AD. And from there, when I create those users, I use something called extended attributes, meaning I'm attaching specific values that you may not typically use, but they actually set up a really cool thing, which is Azure Dynamic Groups. I'll explain that coming up. But regardless, I create the users, and AD Connect, which is a directory synchronization tool for Azure AD, it's going to sit there and it's going to synchronize the users. And then you see that group up there called Gartner IaaS dashboard users, that thing really in the middle. If that extended attribute exists on that user, pick any attribute. Let's call it extended attribute 3. If it has a value like Gartner IaaS dashboard, then I'm automatically put the users within that dynamic group. And from there now, what happens is we use AWS. And so we're using Cognito. Cognito being a serverless computing environment like Azure Functions. It's a way to actually implement functions without having to stand up servers or containers. And for our cases, and for most identity and access management capabilities, using that actually works pretty well. Now, there are going to be times when you have a big job, right, where it's going to exceed a 10-second processing threshold, in which case Lambda isn't going to work for you. You're going to have to use containerization, right? Or same thing would be true with Azure Functions. There is some time limitation on processing. But for our cases of doing reconciliation, what ends up happening here is that the user, Cognito goes and it grabs all the users out of the dynamic group, and it says, OK, let me compare that to what's in the user pool. Cool. And then it goes ahead, because it's running within AWS, it makes all the modifications to the user pool. And then we have now what we've done. Oh, that's looking a little better. Actually, it's only one, right? So now we're moving in the right direction. Moving on up, as they say in the Jeffersons. So now what we've done is literally the circle of life, as Disney would say, started from no users in Active Directory, synced them through, used some specific attributes to put them in a group, and we got them into the AWS Cognito user pool. That's a part of the example. Now, this is relatively well understood stuff compared to the next example, which is a little more cutting edge. But some guidance here. With AWS, our clients frequently struggle with which identity store to use because there are so many, right? And traditionally, they use something called the IAM user store, which really isn't very good because it's not extensible. We can't plug multi-factor authentication into it from third parties. The only one you can really do for this is Cognito user pools. And even then, we're kind of pushing the boundaries a bit. But regardless, when you architect for this stuff and you're trying to do MFA and single sign-on across your applications, you want to make sure that you use Cognito user pool if you want to get that interoperability. Secondly, as I said before, use serverless if you can, right? Otherwise, you'll have to run some containers to run your functions. But otherwise, oh, yay! Thank you. Thank you. I'll be here all week. So when possible, use serverless because it's just so easy and so great, right? And then finally, I know you all do a little of this. You're all doing some testing out there. You're all writing some code. Who puts their keys in the code, right? You're just kind of getting it running, seeing if it works. Don't do that in production. There are plenty of ways to be better than that and easy enough to do. Use AWS Secrets Manager to store the client secret that gets you your Azure AD OAuth access token, all right? Take it out of the code. It's really easy. If you're playing around with Azure, use Key Vault to do this stuff. Finally, and this is really important from a security perspective, it's not as acute when you're doing server-to-server kinds of things like this, when you're doing identity access management across IaaS platforms, but you really need to be careful about the SDKs you're importing into your environment, right? When in doubt, go without. What's that old band thing when you're in band and they say, like if you're not sure of the note, when in doubt, what is it, Sean? Like leave it out, don't play a bad note, something, I don't know. You can tell it's not fully caffeinated, but I'm getting there. Really just narrow down what you use and be very explicit about vetting what you use and put in your environment. You're handling live identities, okay? And as we did in this best case example too, use groups, right? If you're just going to sync all of your Azure AD users at any given time, there's a lot of unintended consequences. The first one being, it's going to take too long. Second one being, you may be syncing more users than you need to give access to your AWS environment, right? Okay. So here's our next example. We've tackled two examples, right? That first example is really good to talk about server-to-server, IAM across IaaS. Now we're talking about client integration across IaaS. So we're talking about single sign-on and MFA across Azure and AWS to manage VMs as if it's one pane of glass, right? And that's the app I wrote. We'll take a look at it here a bit. You can see here, it runs great. It's based on, got a couple things going on here. It manages the VMs across the system, start, stop, reset. Some of you might be asking, why haven't I included GCP within my work here? It's a couple of reasons. First, it's not technically possible for Google Cloud Platform in a programmatic way to take an ID token and give you a local low-auth access token to manage compute engines. Not possible yet. Second reason is this isn't really a comparison of all of the IaaS vendors. If you want that, come see me in San Diego in August. I'll be doing a Mike Tyson full-by-blown style comparison of GCP, Azure, and AWS there. But the application uses a number of different technologies. Again, no SDK needed for Azure AD and Resource Manager, right? Really straightforward. OAuth, REST calls, on your way. You've got to use the SDK for JavaScript. And the way that this starts to work is, first thing is that, and this would be fun to show you, but I'll walk you through it. You use Azure MFA to authenticate through the app. And then you get an ID token, and you get an OAuth token, all right? So the access token, the OAuth token, is used to manage start, stop, list Azure VMs. The ID token, what we do with that is we actually present it to the Cognito user pool. And from the Cognito user pool, we actually get a set of temporary proprietary credentials. That's how you manage things within AWS. There's no OAuth access token within the AWS environment. You're in the process of using these short-term temporary credentials. Now, once that's in place, you can begin to manage the systems moving forward. From an IAM configuration, there's a couple things happening here. The first, on the admin time aspects of managing users and access on Azure AD, got Azure AD, there's a conditional access policy that says if you're trying to manage VMs, you have to use MFA. All right, so we've plugged into conditional access to do that. The interesting thing about conditional access in Azure Resource Manager is you can't be very specific. The most specific you can get within conditional access is not a specific application within the IaaS. It's all IaaS. So when you say conditional access, you're saying Azure Resource Manager applications, MFA. That means everybody gets it or nobody gets it for IaaS resources. It's not specific enough yet. I hope they improve that. And from the access control perspective, well, let me finish up here. On the AWS side of things, we have the user pool. We've been talking about that. From the access control perspective, you've got a role, and there's a construct that I won't explain too much here, that suffice it to say when we build a resource group within Azure AD, that's how we bind users to resources. I can talk more about that. It has a name called Gartner IaaS Dashboard Users. Funny enough, on the AWS side, I've got a role called Gartner IaaS dashboard users. Now, when you're ready to talk sadness and suffering, come talk to me about AWS IAM roles, because they are incomplete. There is no subject within them. So in other words, these are assumed at runtime, not assigned. So it gets very difficult to understand who has access to what in the AWS environment. But at this level, suffice it to say, we've got authentication policies on top, we've got users in both environments to make it work, and we've given them access rights. So some guidance here. Just like my presentation, expect many challenges, right? And I'm so grateful for you making time to sit with me. Many of the capabilities to pull this off, in particular with single-page applications, is undocumented. There, for example, AWS has no documentation on how to integrate Azure AD as an OpenID Connect provider into AWS. There's some specific information that's just not available. And if you have friends, anybody here work at AWS? Raise your hand. Don't be ashamed. Thank you. They were very helpful for me. I have a relationship with them as I do with Azure, and so they were able to help me get it on the way. So that's stuff there, but it's still really early days, and it's not documented yet. Cores. When you develop single-page applications, your browser implements some security features that says, look, you can't make a REST API call from this browser to another resource that's not of the same DNS name. You can't do it unless the resource itself is cores enabled, right? Cross-origin resource, something or other. Somebody will school me, I'm sure. But the bottom line is that unless the IaaS service, like EC2, that is cores enabled, Azure VMs is cores enabled, you're not going to be able to make REST calls from a single page app into the environment to actually manage those systems, okay? And so some support it, some don't. It depends on, and what you would expect is that the IaaS vendors over time are going to cores enable more and more and more of this. In GCP, for example, it's also cores enabled. So you can build a single page app within GCP, no trickery with OpenID Connect and local OAuth tokens, but you can at least talk from a single page app and manage GCP VMs. The actual process of taking an ID token, let's say from Azure, and rehydrating it into credentials, for example, for AWS or for GCP, may not be possible. As I said before, it's not possible within GCP today. Talking with the Google folks, it's something I would expect to see really soon. This idea of programmatically being able to take take an OpenID Connect token and make a REST call asynchronously, right? Because we're doing things with the front end of the browser and managing access and letting the user sort tables and do everything else. But that ability to make a REST call to be able to actually get an OAuth credential at GCP doesn't exist today. And it does within AWS, but it's awfully proprietary, okay? I hope that to change. I know there's tons of people talking about some emerging standards on that, and that's going to get better. So there are also some other challenges associated with running within a browser. The same origin security model actually prevents you from doing interesting things like the ability to be able to open a pop-up window for a callback, for example, to take in tokens like OAuth tokens or other kinds of credentials. You can't do it. It won't let you open and then close. That's a security weakness. That causes problems when you're trying to do single sign-on and catch tokens from everywhere, right? Maybe you want to kind of manage that and take it all in. It's not possible. So this is a pretty challenging environment to do single-page apps across these environments. As I would try to prove to you, had a good laptop and a good session going. It certainly is possible, though. All right, so when you're developing single-page apps for multi-factor and single sign-on across your IaaS environment or into your IaaS environment, you can make a couple of big mistakes. You can use, what we do is when we get our tokens at runtime in the middle of the browser session, we store them so that we can use them to make REST calls, right? So when I get my OAuth access token from Azure, I'm going to store that in local storage, or session storage, rather. Don't store it in local storage. Local storage means that credential lives perpetually. Session storage means you close the window and the credentials go away. Unless you're really smart about handling inactivity periods and OAuth timeouts for tokens and so on, from a security perspective, it's just best to put them in session storage, which means that when you close the browser, they go away, right? Of course, when you're in testing, everybody puts in local storage and everything runs just great until you break it. But think long and hard before putting credentials perpetually within the browser, all right? Know what you're doing. Even more acutely is this issue of using third-party SDKs, because when you develop single-page apps, I use Bootstrap, for example. Bootstrap makes, and now you're going to all like harsh on my HTML skills that look like crap, but it looked a lot worse without Bootstrap. Bootstrap enables you to kind of put things together and make it pretty. Well, do you know what everything that's in Bootstrap? Are you 100% comfortable it's not going to be grabbing tokens on your behalf within the browser? Even more so than service-to-service IaaS MFA and single sign-on. It's too easy to use too many sets of SDKs within your browser apps. So you really need to limit what you have and explicitly vet what you use. And finally, I think this is true across the board when it comes to infrastructure as a service. It's too easy to run everything wide open, right? When you're trying to get stuff running in an infrastructure as a service environment, there's the, you can start and stop all VMs, you can delete them, clone them, whatever else, and you're trying to get things working. But you need to work with your security team after you've got something in development that you begin to scope down what that starts to look like. Now, AWS, to its credit, has come a long way with respect to pick lists of policy creation. Now you don't have to get so nasty into the JSON to craft an expert policy to limit access rights to things. It's really good. It's all pick list driven. So you can really scope down with an AWS now. It works excellent. Azure, not the case yet. There are a number of different roles. There's owner, which is God, contributor, which is everything except you can't actually delegate those privileges, and then there's reader, which means you can kind of look at stuff. Well, contributor is what we give most stuff. Contributor is way too wide for a production implementation if you're trying to manage things at secure levels. So you actually have to hop down to PowerShell and create custom roles. There's no ability within Azure to create custom roles through the portal. You have to go down. And it's not terrible to get out of PowerShell to do it, but you got to go down to do it because contributor is everything, right? Contributor is God, except you can't give God to other people, all right? And then one of the things, just as a thing, and I'll wrap up here, is that our clients are starting to use tagging as a way to unify their IaaS environments, including their identity and access management environments across GCP, across Google, Azure, and AWS. GCP calls them labels. Azure and AWS call them tags. But it's a way to assign a name value key pair. Environment equals Gartner VMs. And then what you can do is you can begin to craft policies that transcend these IaaS platforms by using tags. We're starting to see that emerge as a best practices model for scoping access control and providing a way to figure out who has access to what across all those platforms. That's it for me. I want to really apologize for all the challenges that we had today. I'm really grateful you sat in the room. It's day one or day two for some of you. I saw some of you yesterday who had to sit through this maybe, in the afternoon. You're like, oh, man, I could have caught somebody else's session. That would have been super cool, right? So I'm grateful you stuck around. I'm going to be around, and I will meet with anybody now or next week. I'm happy to do all of this over WebEx to whomever. And if there's enough groundswell for it, I'll set up a WebEx, and we'll all just dial in, and I'll show you exactly how it works. I'll show you those two specific services, the ability to manage users, the ability to provide single sign-on, MFA across platforms as well. So I'm grateful. Thank you very much. Enjoy the rest of the day. Cheers.